So per request, I'm going to give a talk about how to structure large software projects. And I'm going to talk about like my philosophy for how to do design and how I think about like the structure of large things. I recently gave a talk where I talked about how any piece of software should be able to be written by one person, and a lot of people didn't understand or had questions. So it's kind of a follow-up to that. If you want to go watch that, go to Better Software Conference, their channel. I will link to them, and you can see the talk. But this is more of a deep dive of how to actually build software. So let's get going. So I'm going to very brief, sort of hand wavy, develop 3 pieces of software today. And I'm going to make a video editor. I'm going to make a digital healthcare system, because that seems to be something that every government fails at. And I'm going to build a jet fighter. So those are all complicated things. And just before you start typing that I don't know what I'm talking about, I won't go into every detail, obviously. These are huge software projects. There's lots of nuance. And I'm also not really a domain expert in any of these. So I'm not actually teaching you how to write these specific pieces of software. I'm trying to tell you how I approach various pieces of software. So any of these projects, you would need a lot of people who have like domain expertise. You would need to have like people have a good idea of the problems that need to be solved, and so on and so forth. I know a little bit, so I'm going to use that as a stepping off point to talk about how to develop software. But if you want to know details or about any of this, like I've never developed software for a jet fighter, so don't take all of that with a grain of salt. That's not the point here. Okay. So this is about process, not the specifics. So let's talk about the structure. Like, how do we structure things? That's the main thing. And when we plan a big project like this, we want to optimize for certain things. We want to optimize for, or I want to optimize for, dependability. You want a project that lasts forever and never breaks. You want it to be extendable so that you can add new features and capabilities and things that can change. You want to have team scalability, and a lot of this comes down to that you want to have very few people, or preferably one person, working on each section of the problem, and therefore if they are insulated from everybody else, you don't have to have like huge team meetings where everybody's working on the same thing. You want to create a lot of small projects instead of having one big project. And obviously you want development velocity. You want to be able to get shit done, basically. And you don't want, usually with software, the longer you work, the slower things get. And you don't want that. You want, same velocity all the time. And a big portion of this is just reducing risk. Like, things are going to go wrong. That's just life. But you want to reduce it. So what you got to do is you got to think about what your risk profile. What is most likely going to fail, right? And you want to really avoid those problems. So here's some of the things that can change, right? Platforms can change either through API, or maybe they change their terms of service, or maybe they're not hip with the users anymore, or things like that. So you want to insulate yourself from platforms that change. You have language implementations. If you write something in, the hip, cool language today, if you're building a system that's going to be around for, 20 years or longer, like a jet fighter will be around for 50 years. A healthcare system will probably be around for close to that, right? A lot of the video editors are from the 80s and 90s. So having software that can live for decades is really important. And therefore, you need to make sure you write it in a language that there will be compilers for in the future and things like that. And then obviously changing hardware, changing priorities. You may need certain things in the future that you don't need today. And you may lose people, right? So what happens if your star programmer leaves the thing? These are things you really want to worry about, right? So a lot of small chances of failures equals a big chance of failure, right? A lot of little things that might be easy to fix, if you have enough of them and they happen frequently enough, things grow really, really tiresome, right? So even if things, a lot of people say, well, that's a trivial fix, a compile error somewhere that you can just like fix. That might be true, but if you're working on something and all of a sudden your software stops working because somebody else added a little problem, you have to context switch and stop working on that and fix this other thing. And it grinds to a halt. You have to look at code you don't understand and things like that. So you really, really want to avoid like even the small speed bumps, because as projects grow, you get more and more of those speed bumps and you get more and more problems. So I'm a C programmer. I use C89. It is the most dependable language you can have. It will compile everywhere. It will last forever. It works, 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 works. I am currently actually trying to document what I call dependable C, which is like the subsection of C that you can depend on. And it's mostly C89 if you want to be really safe, but there's some parts of C99 that are pretty safe to use as well. But really, these rules, it doesn't matter what language you use. Like you can apply all the other things. Like if you could use C++, you could use Python, you could use anything really to write this. This is not a language specific thing. However, I do think like language is one of those risks. Like Python just broke everything when they went from 2 to 3. Like if you have millions of code that are in Python 3 and they decide to make Python 4 and break the backwards compatibility, you have a major problem on your hands. So yeah, this is kind of the rule. It's like it's faster to write 5 lines of code today than to write 1 line today and then have to edit it in the future. You really want to finish your code. You want to write code so that it never breaks, right? And if that means typing a little more, being a little bit, more explicit about what you want, that's a good thing, right? Because you're thinking about it now when you're writing it, and going back, 5 years from now, trying to figure out what it does and fixing it, even if it's a trivial fix, is really, really hard, right? And it stops working. You want things that are really dependable. You leave code when it's done, when you know you're not going to have to go fix it in a couple of years. And that's really, really key. So you want to modularize your software, right? If you're going to have multiple people working, you want to modularize. So how do we do that? So in my opinion, modules should be pretty much black boxes. What they do should be exposed through APIs or protocols. So you talk to it and it has an interface that you can document that is clear and you understand. And then whenever you want to use it, you talk to that, but you don't actually have to know what's behind the scenes, right? Somebody wrote it, it's rock solid, it just works. You don't have to know what it does. You never have to look at the code. You don't have to integrate with anything outside of the API. The API is documented, and this is why I like header files in C, because you can have huge amount of code and then hide it behind one header file that says, here's all the functions you're allowed to use, here's how you access all the functionality, how I implemented that, you don't have to care about because I solved it for you, right? So this means you can have one module, can be one person, right? And that's really key, is like you can really split everything into small modules, and each module can be one person, right? And you have multiple modules. And that's what I mean. Every piece of software should be able to be written by one person. And by that means, it's like you split it down to modules, and the modules are small enough that one person can write it. And at some point, somebody is going to sort of write the application, and they do that by taking a bunch of existing modules that other people have written and just merging them and using all those things to do the thing, right? And that's why you can have essentially a single person writing all of these pieces of software that we're going to discuss today. So yes, obviously you can have good programmers that can finish a module and then make the next module. That's fine too. But the rule is that you should really avoid having multiple people have to work on a single module. You may have lots of people working on designing a module or like deciding how the API should work, but I really think it's good to have only one person implementing it. So yeah, some modules are going to be senior and some are going to be junior. There's going to be modules that are hard to implement and there's going to be easy stuff. So you want to really think about that and give the hard modules to your senior people and, the easy stuff to your junior people. And this is a really interesting thing. What if that module breaks or is terrible in some way? Well, if you have an API for it and that API is good, you can actually re-implement that API in a new black box that uses, different algorithms, different everything, and all the software is using that will still work, right? And that means that if you have a piece of software that is owned by a certain person, you can actually, if that person leaves, you can rewrite that from scratch and then gradually move to the next version. And that's really, really powerful. So let's talk about the video editor. We're going to talk about, a basic video editor. So it's a native application with a UI. So let's start there, right? So you're going to want a stack that looks something like this. You want a platform layer. You want to open a window and do things like that. You want to be able to draw, lines and things. And then you want to be able to do text. Text could be in the drawing library. And then you want some UI things so that you can do a UI for your application. And the text can also be in the UI. It happens to be in my UI library. So you really should wrap your platform layer. And the idea here is that anything that you don't own, which would be the platform, you should not talk to directly. You should make a wrapper around that. And there are a bunch of wrappers out there. So for instance, SDL is a wrapper you could use. However, even if you use something that is online and open source and generally really good, you still don't control that, right? You don't know the direction of their development. You don't know, if you're going to need something else. If you need to add functionality, you don't know if they're going to accept your patches. So even though you're using, something really good, you really want to wrap it so you don't actually have a bunch of calls directly to code you don't have in your code. So I can show you this. This is betray.h, which is the header file for my wrapper. And it contains all kinds of things. But it allows you to open a window, just get input, lots of things. And this was actually implemented over SDL from the beginning. But SDL didn't have, this was SDL 1.0, so it was a long time ago, but it didn't have all the features I wanted. So I made another backend that was Win32, and then we've gotten lots of other, operating systems. But this really gives you the control over the platform. Then you want to definitely write a demo application, test application. So I happen to have mine here. So this is my little test application. And this is a minimal application that just opens a window, reads mouse pointers, draws something. There's like some buttons here that do things. I can click on here. I have a little window here. If I scroll my window, I get all the events. So this is like really, really useful when you try to port this API to another platform. Because if you're building a huge video editor with lots of, millions of lines of code, you don't want to have to port all of that code over to the platform. You want to start with something very, very small and very simple. So therefore, it's super useful to do this. Usually you write this while you write the platform layer because you need something just to test that what you're doing is correct. So this is a great little thing. So I can show you, hold on. Here is a screenshot of the same software running on Android, and it's run on lots of other things. And this is like when you move to a new platform, this would be the first thing you do is just get that going. And here is, the file. So it's not huge, but it draws some stuff. It basically tries to exercise all of the API. Now, normally when you actually implement this, you tend to comment out most things. So you start with just like open a window, and then when you get that working, you're like, okay, now I'm gonna comment out, like read the mouse pointer, and you know, as you work through, eventually this whole application will run on the new platform. So there are things to consider when you do a platform layer, and what those are depends on your application, what you want to do. But like, what kind of inputs do you want? Screen resolutions, aspect ratios, scale. Do you want cut and paste? Do you want file requesters? Safe spaces is getting more and more important, meaning basically, your window may be this big, but maybe you're on a phone and there's a notch in the way or something like that, or round corner, so you shouldn't really put text there. So you need to be able to detect which areas of the screen are actually safe for UI or for information. And then you might want to support things like multi-user. So my layer has not just input from multiple input devices, but also from multiple users. So for instance, you can have two controllers, and therefore those are two different users giving input. And therefore, my API supports things like having two mice and two keyboards connected to a computer, and therefore you can, in my UI toolkit, you can click, one user can click with a mouse pointer in a text field and start typing, while the other user clicks in another text field and starts typing, and the typing will go to the right window. Now, right now there's no platform that actually supports that. So Windows doesn't properly support that, and I don't I don't know of a platform that supports that. But if there is a platform in the future that will support that, all my applications will just work, which is super useful. So then you also want to consolidate a lot of functionality, right? You want to take all the disparate things that you could have on a platform and make them one thing, right? So, in my example, all buttons are the same. Doesn't matter if they're on a controller, on a keyboard, or a mouse. Doesn't matter. All pointers are the same. So mouse pointer is the same thing as a touch. So basically, we have multi-touch, multi-pointer. They're all the same. And you just, a touch is basically a mouse pointer that doesn't move when you're not clicking, and that only has one button, right? And the same goes with axes, so that would be joysticks or pedals or whatever input you have. It gets a little bit more complicated. We'll get into that later. So now you want to do a drawing layer. You need, basic things to draw a UI if you want to do something. You want to draw lines, surfaces, images, maybe shaders, maybe geometry. It depends on what you're trying to do. This is mine. This is Relinquish. It's built over OpenGL, but it actually designed so that you can run it over Vulkan or any backend, and I'm hoping to implement that at some point. And then you want to do text, obviously. All applications need text. And here's kind of an example of how I would implement it. Like, you can implement the simplest possible text. So you can take, a font you find online like this one that is like just a bitmap font. You load it in, you make a bunch of, squares, and you draw this, right? And if you implement this, you can make a simple function that draws text. Float, there's supposed to be. You can draw this really, really easily, right? So since you have this way of thinking about black boxes, now you can actually make a black box that draws text, and it can be super simple, like a bitmap text. It doesn't do anything complicated. But once you have that, you can, people can start writing UIs that have text, and then you can go in and you can have, proper font loading. You can have, all kinds of good stuff, right? So you can do true type fonts, or, anti-aliasing and kerning and all that stuff that you don't care about, right? So this is a really important thing. It's like you can give somebody an API for something that isn't actually finished. Like it draws text, but it doesn't draw nice text. But that's fine, because other people don't need nice text in order to be able to start building interfaces. They just need text, right? So this API that I'm showing here is actually not very good, because this one doesn't get you all the things you want to do. So I'm going to show you, this is my function for drawing text. It's actually one out of many. So for instance, you want to give it what font, you want to give it, the size of the letter, the spacing of the letter, the text, and you don't want the text to be ASCII, you want it to be UTF-8 or something like that. You want a color, and you want a length specifier, so you can limit how long so you can just print a part of the text. Now, and then you want it to return how long the text is, right? So even if you implemented it using this stupid font with no kerning and nothing, you can still build this interface for it, right? Maybe the font is, just null for now, and that gives you the default font. And maybe there's only one font. Maybe you can't choose fonts, but you still have a font parameter there. And that means that people who start writing this can start writing code as if it was done. And then when it gets done, the text will start looking great, but will actually, nobody has to re-implement all the places where they use the text functionality. So this is really, you want to learn how to think forward, right? You want to think, what are we going to need in the future, right? And really avoid implementing, is good enough for now, because you want to finish stuff. And if you have to, you know, text, for instance, you may not want to do Arabic, which is backwards and things like that, or Korean or things like that, right? Maybe your product team can't wait for you to implement that because they need to ship something, right? So then you can implement something simple, but you never implement a good enough for now API. The API is the same, you think through, I'm going to do Korean at some point, so let's make an API that is good enough for Korean, and then people can use that, and even if you can't draw Korean now, it will in the future, and they won't have to change their code. So that's really, really important. And then you can, do the same thing, build a UI toolkit. I have a UI toolkit. This can be modularized. Mine is one big UI toolkit, but you can modularize it for button and things like that. And I would argue that making a UI toolkit is relatively easy. Like buttons are easy to implement, sliders are easy to implement. The only thing that is kind of tricky to do in UI is text input. So not relying on the operating system, not relying on a platform is not a big deal. And especially if you're making a portable thing, a portable application, and if you have to figure out how like 3 different platforms do a slider, you're going to need more time to do that than to implement your own slider. So you just make a slider. So now we have this, which is like our base layer. Now, one of the things you might notice is that like you can actually, none of this has to do with the video editor, right? This is just like stuff you can build anything with, like any desktop or mobile app, you can just write it, right? So once you've done this is actually a superpower for yourself or your company. And to me, it's like amazing that like large billion-dollar software companies don't own this. Like they should just have this so that they quickly can make whatever product they want to make in the future. Like you should not have to rely on the operating system to draw text. If you're, even if you're a small company, you should be able to do this. If you're a huge company or a big company, you should definitely have this as part of your toolkit. So yeah, these are all sort of helper libraries, right? And you really want to put as much as you can in helper libraries because helper libraries can be reused for any project, right? So file parsing, physics engines, scripting, data storage, networking, all kinds of stuff like that, right? So for instance, for networking, I have Testify, which is a library that does all of the things you need to do, and it can figure out what kind of network you're on. It can do, all kinds of stuff. It opens up ports with port forwarding protocols. It can find peers. It can do all kinds of stuff. And it's really, really powerful. And it basically means that I never have to care about like the socket API ever again, right? And I can improve this under the hood. So there's capabilities of like how to connect and how to, do certain things that I can improve under the hood without changing any of the applications that use it. Okay, so now we're getting to the core, which is when you're actually starting to build the application you're building. And this is kind of the majority of this talk and how to build a core. So what are the things we are editing? What is the thing that this application does? How can we generalize what it does, right? So in my opinion, a video editor is not something that edits video. It edits a timeline, right? It's a timeline, a bunch of clips that overlay each other, and they're in time, and you can, from that, you can generate a video. You have a bunch of clips, you have an input data, and then you have a rearrangement of that input data, and then you get an output, right? So we can think about this as clips on a timeline with animated parameters, right? Because we're going to need parameters. We want to zoom in, we want to color correct, we want to do titling, we want to do all kinds of things. So those are going to be parameters that these clips have. So everything is a clip, right? Now we've made it really generalized, right? And this is really key. It's like if you can generalize things, you can make really nice software. So Unix, everything is a file, right? And that means that, lots of stuff in Unix are compatible because it's like this takes a file, this outputs a file. You can connect those together and things work, right? Software like Houdini, I think of a screenshot here, is basically a node graph. The whole software, it's a big visual effects package. It's basically one big node graph where each node has parameters on it. That's what Houdini is, right? And Notch, I just want to bring up because they're awesome, is the same thing. It's a node graph to do visual effects, right? So these are, basic structures that you can put your whole application into, right? If you take something like Unreal, it gets more complicated, right? Unreal is C++. It's a bunch of C++, but there's also blueprints and there's also a scene graph with assets. That means that you can't generalize everything quite as easy. And you end up with a situation where like, oh, we've done this in Bluetooth, in sort of blueprints, sorry, but we wanted it to be in C++. Or we did this in C++, but now we can't access it the way we want it in blueprints. Or is this as an asset? Is it blueprint? What is data? What is, it gets a little bit more complicated. And this is not directly to critique Unreal. Unreal does very, very complicated things. So sometimes you can't simplify things like this, right? The world isn't as simple as you want it to be, right? So what you want to think about, and what I think a lot about, is something I call primitives. And primitives is sort of a word I borrow from computer graphics. I have a computer graphics background, so I think in polygons or things like that, and we want to talk about polygons, right? So if you want to make geometry, you can define them by polygons, right? So typical, here's a Utah teapot. It's a bunch of polygons, like little triangles or quads. And that's a very simple way to express 3D data. But you can also think about other ways of doing it. You can do NURBS. They are mathematical curves. They can actually do, curves. Polygons can't do curves. So if you want to do a car modeler, NURBS are way better. But NURBS are really, really complicated mathematically, and they're not easy to deal with, and you need a lot of code to manage them. You can also do something like this is teardown. So teardown, everything is built out of voxels, little cubes, if you will, even though they're not. And that means that it's super easy to do collision detection, it's easy to do destruction, it's easy to do a whole bunch of things that are super hard to do with triangles. On the other hand, there are things like making a smooth surface with a bunch of little cubes is pretty much impossible, right? So you win some and you lose some, basically. And then, we can go further. This is, signed distance fields, which are, a new hot way of doing mathematical shapes. That gives you a bunch of other advantages and disadvantages. Or, my favorite is subdivision surfaces. This is from my subdivision surface modeler, which gives you a poly mesh that gets rounded into a smooth surface, or a smooth-ish surface. But which one of these you choose really makes you choose what kind of software you're building. And some of the more advanced softwares like Maya and others, they allow you to have multiple different representations of geometry. But that also means you get a lot of complexity in your software, because now there's functionality you can do on NURBS you can't do on polygons, or things you can do on your voxels, but you can't do on your polygons. So you have to convert back and forth, and you get lost, and it becomes really complicated. So if you can find a primitive to store your data that is consistent and that works for everything, that's really, really neat, right? So Unix, let's talk about Unix some more. Like Unix is a good example actually of this. So Unix, everything is files, right? Pretty much text files. They're not any file. And that means you can grep it for a piece of text and you can find it, and that's great. But it doesn't work for, like, you can't grep for a quote from, MP4 file that contains Casablanca. You can't find all the good quotes because grep works on text, not on video, right? So by limiting yourself and saying everything is a text file, you can do a lot of things with text files, but when you want to do video editing or image editing or something that isn't text, Unix and the command line is not really a good interface. And here's what I want to talk about primitives versus structure, right? So in Unix, you could say that the structure, how we use this, is we use command lines with pipes to pipe things between applications, right? But the thing that moves between the applications, the format of the data that goes from A to B, that is files, and that's the primitive, right? And if we change the primitive, we could make a command line system where you can pipe video from A to B, and then the primitive would be video, but we'd still have the same structure, right? Or we can also have a structure where we have, a UI as a node graph, but where through the cables we push text, right? So we use the same primitive. So these are two different things they have to think about, like when you choose how to design this, right? And here's an example. So Photoshop has the structure of a bunch of layers, which isn't really true in modern Photoshop because Photoshop is complicated. But we can think of it as a bunch of layers of bitmaps, right? Whereas Nuke, which is a compositing software, I have a screenshot here. This is a node graph from Nuke that allows you to composite, video essentially. The primitive is still bitmaps. There's still bitmaps moving through this thing, but it's a tree structure now. So again, both of these, they're not really always bitmaps. They can do curves and things like that. But sort of generally, you can think about these as two different things. So in our case, when we want to do a video editor, we say that all tools that we want to make operate on clips, right? When you move in your timeline, you're basically editing a clip or you're changing parameters of that clip. That's all you do. All the UI, everything does that. That's what the application actually is. So we want to build a black box that stores this information, right? Stores a timeline and have an API so we can access it, right? So an example of something that actually exists that does that is OpenTimeline.io, which is an open API, Python API to create a timeline. But you would probably build your own. So when you build this core that keeps all your data from your application, you can enforce these kind of guarantees. So in our case, we kind of want to do certain things. For instance, we want, clips not to have negative time, or, maybe we want clips to never be longer than the asset they are using. Maybe we want, consistency in time. Maybe we want whatever we think is important and that we want to guarantee. And that means that when APIs call this, they don't have to care about that, right? They know that the data is going to have, certain requirements and be clean, if you will. Another thing you might want to do is undo, right? Other application can just say, change the clip like this, and automatically this, storage container will actually manage figuring out what the changes are from the last version and be able to undo those. So therefore, you want to build that into your core structure. Okay, so what kind of clips do we want to support? Like, we want to load all kinds of video, right? So how do we do that? Well, if the core has a definition of every clip you could ever want, every video format, every effect, everything, then the core is huge and it's not possible for one person to write it. So we really, really don't want to do that. So we want to build a plugin architecture. We want to build an API where, a piece of code can go in and say, I can do this. I can show you video of MP4 and I will give you this information about the length and resolution and things like that. And I will need, the speed you want it to be played back at, and the default of that is, 1x, and, you want to describe this plugin basically. And this plugin, so you basically get something like this. This is my structure for this. So you have a core with a bunch of plugins, and then we have our UI toolkit. The core here doesn't actually have a UI, doesn't do anything. It's just a core, right? That you can read in plugins, and then you can access the plugins. So let's have a look at what you want to write next. Well, you want to write a launcher, right? You want to write something that starts up the platform, starts up the core, loads in all the plugins, and actually does something. So in my case, let's see, I think I'm missing something here. I'm going to show you some demos of this in a second. In my case, this might be enough, right? You might just have all the UI and all the APIs here, you just write a UI for, right? If that's a simple application. And I'm going to show you a simple application. So let me show you an application I have written that works kind of like this. So this is Stellar. It's actually Stellar 2.0, which is an application to control lights. And I'll show you a little bit about how this works. So here is a 3D world, and here we have a light fixture. So now I looked on the network and happens to be a light fixture there. I can create a collection of light fixtures, which gives me inputs. And then I have a bunch of these, which are things that do things. And these are plugins. So all the effects in this application are plugins. So I can, for instance, create a sphere, and I can connect this to this. So now you can see I have a sphere here, and I can actually move this sphere. I can change parameters. I can make it a little fade. I can change the color or whatever I want. And then this application happens to be a node graph, as you can see. I can bring in other things, like I can create some motion here, connect this to motion, and then run it on a loop. So now it moves very fast, right? So now I've created a simple effect, right? And I can bring in some other things, like I can bring in color ramp. So I'm going to take this ramp, sorry, and I'm just going to make it slightly smaller. So I'm going to connect this to the ramp instead. So now it gets a single color, and then we're going to drive this ramp with this thing. And now I can say a color here and another color here, and let's make it black here, right? So now we can remap and do all kinds of stuff. So this is kind of what this application does. But if we look under the hood, you can see that actually all of these are plugins. Even this is a plugin. It's a built-in plugin that just sort of magic plugin that talks to light fixtures. And then these are all just describing what they do. So if we look at the internals of this, this API is what you build your UI from. You basically say, here's to create an effect, and you can create nodes. You say which node you want. You can get all of the, you get the descriptor that tells you what parameters it has, and then you can set those, and you can build basically a UI. So this little thing is all you need to really build the whole UI, right? So the core can be kind of small, and then you, on top of that, build a UI. And that means I can rebuild the UI without ever rebuilding the core. And one of the things about this application, which you might want to do with a video editor, is you can actually take your core and make a separate application. So let's say you have, your video editor, and then you save a video editing file. Maybe you want to have a command line tool that can just take that and process the video for it because you want to run that on a server or something like that. Well, then you can have the core, and then you skip all the UI, all opening window, and just make a little command line thing. And all of the core of the application that does all the processing is completely separated from the UI. And we can actually, I will show you a plugin. So here is a file that is a bunch of plugins. And what you do to create a plugin is these live in a separate DLL. And that means that the application stays kind of small, and you can have people writing DLLs, and you can add those one by one. And those people can basically work completely isolated. They don't have to know the people who write the core. They can just follow an API and make any plugin they want. And most of the interface, most of the functionality in the application sits inside of those plugins. So here's kind of a simple way. You say, hey, I want to do a sphere, which was the effect we saw. It will output color. It's part of a shape, some text you can put in the UI that describe what it does, and then you list all of the inputs of it, what they're called, what the default values are, a little bit of UI hints of how you might want to draw this, and then you also give it a function. And if we go to that function, this is the function that actually does the computation, right? So this allows you to implement new features really, really quickly. So, and actually, just to be really nerdy about it, this API, this kind of plugin API, I also have that for Betray, which is my platform library. So if we look here, this is the platform. This is a plugin for doing controllers on Xbox controller, basically Windows controllers. So that means that when I build my system, I don't have to link in special code for Windows. That's a separate plugin that can be built separately, and therefore, I don't have a dependency on that. I only have a small DLL that has a dependency, and the system will work just fine without it. It's just sort of an optional thing, and that means that you can have a lot of little dependencies, but you don't ever need all of them to build it. You need almost no dependencies to build the project, but then you can add the stuff you want. Okay, let's move on. You want to present information and capabilities. And this is kind of a pattern that comes up almost always to me. And when you build structures for things, you want to be able to have things say what they can do and what they can tell you, right? So here's like a very simple washing machine, right? If you look at these two structs, what am I doing? You can think of type def. It's like, I'm a washing machine. I'm currently running, and you have an enum for what kind of mode you're in. What's my current temperature? What's my current load? And how many seconds do I have left, right? If you get this information with the information of the structure, like if a washing machine can say, these are the parameters I can tell you about myself, that's all you need to build a UI, right? You could build an app that works with this, right? And then the same thing is like, you need a struct to say, basically, here's the parameters you need to send me in order to tell me what to do. Like, you need to tell me if I should run or not, and which mode, and at which temperature, right? And I can't, for the life of me, believe why the people who do IoT stuff can't get this right. But really, you don't have to know that it's a washing machine to build this system, right? All you need to know is, this is the stuff that it wants to tell you. This is the stuff it needs to know, right? And whether that's a washing machine or a toaster or whatever, doesn't matter, right? And I'm actually working on a project called Marshall, which I hope to make a new video about, that will solve a lot of these issues. Okay, so here's our new updated design. We might have a core, a bunch of plugins, but we may also have a launcher UI and then plugins to that, right? So if we have a complicated UI, we may have a launcher that starts it and then says, okay, there's a bunch of panels here. The panels that show information, they are themselves plugins, and they talk to the other plugins and do the graphics. And therefore, we can split up the UI. So we have one engineer doing just a timeline and one doing, the video view or color correction or like all the different sections. We may split those up and not have one code base, right? Okay, so let's build a healthcare system. And you're going to see that it's very, very similar. So first, obviously, you want to figure out your requirements. You want to figure out what's the primitive, what is the data that flows through a healthcare system, and maybe medical journals, right? That's what people think. Well, probably not the greatest things. I think we should probably have healthcare events, right? Because if you think about it, your healthcare journal is a bunch of events, like starting with you being born and a bunch of things happen. Every time you go to a doctor, that's an event, right? And what's neat about that is you can then also have future events like your appointments. And you can also access the data in a different way. So you may, for instance, want to say, I want to get all of the healthcare events at this clinic today, right? And that means I want to access everybody who is going to be here and when they're going to be here today, but I don't want their full journal, right? I might be a clerk somewhere. I'm not allowed to read all of the information, but I need to know who's going to be here. I need to know when there's a gap in the schedule, and I need to know that, right? So let's go with that. Let's say we're doing a bunch of events, right? And then we do exactly the same thing as we've done before. We build a black box, and here's what people start out with. They say, well, what kind of storage would you choose? Would you do SQL or blah, 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 or Amazon or whatever? And that, to me, is completely the wrong way to go about it. What you want to do is, what are we storing and how are we accessing, right? And that is a black box, how it's actually stored, right? So I would probably store it at some kind of open source thing that I would find good. You can write your own or whatever. But to all the users of the system, none of that matters, right? And that means you can actually change your storage anytime you want. You can rewrite it and go somewhere else, right? You don't want to lock yourself to, Amazon or a certain vendor. You don't want to even lock yourself to, MySQL or something that is stable and open source. Who knows what you're going to want to use in the future, right? So you really, for the users of the system, they shouldn't have to know. They shouldn't have to do SQL calls because there might not be SQL behind it, right? You need to make your own interface for how to access this thing. And that means you're way more flexible. Okay, so the second thing you can do once you built this is once you have an API between your black box, you can take whatever old system, because guess what? Your healthcare system probably has something ancient that you want to get rid of, but you don't want to switch over, right? That's what a lot of projects like this, they fail because they switch over, right? And the switch is really, really painful. So why do that? So what you do is you write a little piece of glue code that uses your Access API with the old Access API and just moves all the data between it. So when you get a new event or new data into your system, you move it into the old system. When the old system gets something new, you read that out, put it in the new system, right? So now nothing will break. Now you can gradually move over, right? And this is super useful that you don't want to have this breaking change where you say we go from system A to system B. No, you want to have both systems at the same time, right? And then you can start doing other glue codes on top of this, right? So let's say you have this black box. Maybe you want to have multiple APIs to use it, right? Maybe you want a C API, but hey, nobody's going to write C, right? Maybe the hardcore people want to write a high-performance C thing. But most developers aren't going to use C. So you can make a C++ API on top of it. You can make a Python binding. You can make all kinds of bindings on top of this. And they just use the same API. And then you can get your hardcore C++ nerd to write the perfect C++ thing. Actually, there is no perfect C++, but whatever, right? You can have different people writing these glue codes that gives people multiple ways of accessing the system without needing, to basically use the core APIs. And then, of course, when there's new languages, new capabilities, or new ways people want to access, you can write new glue codes, right? And Then you can write stuff on top of that. So on top of your glue, you can say, well, now we take data out of the black box, and we send it over the internet, and now we can write an app that does something very specific, right? So we can have hundreds of different apps for different kinds of healthcare people, for machines that do things with healthcare, and they can all report back through the internet, and they can use their own way of talking, just as long as it ends up in one of these sockets, right? And now we can build a website, right? So we, let's say we use Python, so we can take a Python API, and we can generate a website, and you can use your browser to access the information, right? So you can sort of fan this out and grow a tree of stuff, but everything goes through this central black box of thing, right? Now, in reality, that black box might run on one machine or 1,000 machines, or but to the users, to these applications, it's just an API you talk to, and you don't have to know what happens in the background, if there's a big server infrastructure to store all this data, how it's sliced and diced. None of that you have to care about, because this is an API to you. So let's build a jet fighter, okay? And you're going to see that it's pretty much the same thing. Okay, so we have lots of things here. We have lots of sensors, weapon systems, like capabilities forever, right? And a lot of these capabilities, we don't even know what they are, because if you build a jet fighter today, it's going to be around for 50 years. So who knows what kind of missile or drone or sensor or whatever you want to put on this thing, 25, 30 years from now. So even if you can probably survey this, and you can probably have some really smart people who can tell you all these things, even they are not going to be able to know. So you can't really architect a system knowing what it's going to be, right? Okay, so what is a primitive we might be able to use? So we might say, well, the primitive here is the state of the world, like whereas a healthcare system cares about history, a jet fighter mostly cares about what's going on right now, right? It wants to know, where are all the contacts, where are the enemies, how much fuel do I have, how many bullets do I have left, which radar can detect which object, what's the wind temperature, all kinds of things, right, that all these sensors and things are giving you, right? And you want to care about some things that are specific to, aircraft. So, you want to have confidence, right? How much do I trust this thing, right? And you may not trust everything in a war, turns out, right? You want accuracy, right? If you have two different things that measure the same thing, you want to know the accuracy of those things, right? You want to know what the source is, right? So if you get temperature from something, you want to know what the source of that temperature is. You want to know what the format is, right? So you might have multiple formats of things, like maybe I want to know where the position of this enemy. Do I want it, in relation to the jet fighter, or do I want to know where it is in the world? Like, those are two different things, two different ways of asking where a thing is, right? And then I want a bunch of capabilities. Like, I want to know, if you put on a missile on the plane, you want to know, what can this missile do, right? And when you fire it, you want that capability to be gone, right? And you want people to be able to add new capabilities, new missiles, new things, and then the system should be able to understand that now you have a new capability. And then you probably want to have things like damage, like things, accuracy may go to 0 if somebody has blown off a sensor or something like that. Okay, so you want to build, again, a core, right? Black box to store this. So what you do is you make an authoritative core. You make a core that has, like, here's the world according to all the sensors and all the stuff. This is the current state, right? But then you're going to have lots of little computers around, lots of systems, every radar, every, the displays. There's going to be computers everywhere, right? So all of those need to know the state. So then you need a protocol so that they can subscribe to information, right? You probably want to have a subscriber model where, a certain, the engine wants to know, the humidity, and it wants to know how much fuel or the altitude and things like that. But it doesn't need to know, like, how many radar contacts you have. That's not interesting to the engine, right? It doesn't care, right? So you want to basically, and you're going to have some parts of the plane that are going to have really powerful computers, and some parts are going to have like microcontrollers. So you want to be able to subscribe to the information you want. You want that to be push notified to you. You may have different rates, how often you want the information, and things like that. And once you have that subscriber, you can then, on your local chip in your local memory, have, a partial state of the world, right? And you can then use that to make decisions, right? And then you can even, when you build this system, you can say, well, we might want to have different ways of encoding this information between the subscriber and the authoritative core, because we may have different types of cables, different types of, hardware connectors, basically, right? We might want to support multiple of those with different bandwidth, different requirements, what have you, right? But this still means that if you're building a piece of equipment for this, you now have a stable API, an API you can call to know what's going on and to send information. So if you're building a radar, you can, get the humidity or whatever you need from the system, and then you can send all the contacts you find to the authoritative core, and the authoritative core can send that on to, the pilot or the visualization system or the screens or the head-up display or whatever system is interested in that information. Okay, so it's not really a storage system here. Like, here's the pass-through system, right? You're passing data from one end of the plane to the other. And you can obviously store as well if that's a requirement. And here is a really important thing that goes for all of these projects. And that's, if you build something like this, you want to do a lot of tooling, right? So let's say we're building a new jet fighter. We haven't figured out what it's going to look like, but we build this core, right? And we're going to have all these different contractors and people building missiles and things, and they all have to somehow connect to this thing. How do we do that, right? They can't, like, how do you test a missile when the button in the that the pilot's going to press isn't done yet, right? So therefore, you want to have lots of toolings, right? So you want to be able to take all the input from various things and record it, right? So now you have a black box recorder, right? Because all the information goes through this thing, so you can have a little recorder that subscribes to all the information and stores that, right? Great. And then you can have a playback. So now if you have, your first flights, you can record information, and then you can put that to a missile and say, behave, here's a real flight that we recorded, here's all the data from it, now we can simulate that, right? You may want a Python API because maybe you want to, when you test a certain thing, you want to simulate that, something happens, like what happens if this goes away or the radar stops working or whatever. Now you can simulate things. Like you want a logger so you can see what's going on. Maybe I'm just implementing my radar and I need to be able to see when the radar outputs, that it outputs correctly, that the data coming into the system is correctly. Just having something that can print it on screen is like super useful. You can have visualizer to see what's going on. You can have full simulators, right? And all of this code that I'm showing on the slide are stuff that are never actually going to go into the jet fighter, but that are going to be really, really helpful because it allows all these separate people who are trying to write to this code to be able to get the code to do what they want so they can test their code, right? And that's going to help them once you actually start putting the plane together and all these pieces talk to each other. If you can have a missile and you can simulate what the cockpit does, and then you can record what the missile does, you can send that recording to the people who make the cockpit, and they can say, okay, this is what we're expecting to get from the missile when the missile's firing or when the missile's finding a lock or whatever the missile does, right? And this would go for almost all the projects I've talked about. Like almost like always write a bunch of tools that you can get your data out of your black boxes and or your core boxes and make them do things. At this point, this black box doesn't actually know anything about aircraft, right? It can't actually do anything. It doesn't do, avionics. It doesn't do target tracking. It doesn't visualize anything. It doesn't do anything. It just passes data through it, right? And we're not actually giving away anything secret here, right? So this could actually be open source, right? You could give this away to anybody, right? You could put it on a website and says, this, we're not going to tell you how far a missile goes, but here's how our missile tells the system how far it can go, right? And that means you can have all these contractors that can have these manuals and go out and try to build parts, and you can have an open bidding for making stuff that fits into this plane, right? And that makes it a lot easier to do things because you've removed all the secret stuff. You're just saying this is how we collaborate, but the actual secrets and how it actually works, that's up to the endpoints. And yes, I know that no real military would ever make anything open source because they don't understand this kind of things. So yeah, now people can add all these bits. Now people can add sensors and weapons and UIs and connectors and all kinds of stuff, right? But then you say, well, this is a crappy system because now we have everything centralized. It's bad, bad, bad. Like what if, somebody blows off this computer that is running the core thing? Now everything is terrible. The plane crashes, nothing works. That's true, right? So that's a requirement for a jet. Like jets have redundant systems. So you can't have like one central core where everything goes through, right? That wouldn't work. Well, you could easily build multiple cores. The thing here is that you can have any number of cores that sits on lots of different computers. You can have lots of interconnects between all these systems that are redundant and over-redundant, but the subscribers get their information through the same API, right? So that means you can make a single core that's very simple to implement. You can implement that, give that to everybody. They can get started on their missiles and equipment and all this stuff, and then you can spend 3 years making this advanced system that has multiple cores that vote on which is one, that can detect which one has been blown up and doesn't work. And you can build all that, and then you present to the same people, here's the same API, the same way, you get the same information. It's a drop-in replacement, right? But instead of waiting 3 years to get that, everybody could get it, in 6 months, right? And that's really, really core to this black box thinking. You can redesign the inner core to be more complicated. And sometimes you do that, because you figure things out. And sometimes you do it because you need to get product out. So this is exactly the same thing as we did with the text rendering. We started with simple text rendering, but with the same API. And then we made nice text rendering afterwards. But the users of that API didn't need to change anything because it just works, right? Okay. So here's a cool thing. You could put this in a tank now, right? It doesn't have to be in a plane. It could be in anything, right? Now that you have connection between things, you can connect multiple planes together. They can share this information, right? So now instead of saying, I got a radar lock because my radar found this enemy, you can have my neighbor, the other ship, fighter found it, or the ground radar found it, or anything found it. It doesn't matter, right? Because now you have a way to communicate about the state of the world, right? And you're obviously going to have lots of encryption and lots of things to control what you want to get in and out. But really, once you have a system like this, you can, make it very generalized. It doesn't have to be in a fighter jet. It could be on a transport jet. It could be, on a tank. It could be on anything. And that means that now the people who make missiles, they may want to make a missile that can be launched from a tank and be launched from a plane, and they have the same interconnect, right? They don't have to write 2 software stacks to control these 2 different things in 2 different things, and things become a lot more interconnected. And even if there's going to be lots of differences, you can actually have the same know-how, and people will know. People can move from different projects, and they know, oh, when I talk to the system, this is the API, this is how you talk, even though the thing I'm doing now is completely different hardware-wise or capability-wise from the last thing I was doing. Okay, so let's wrap up. I've talked for a long time. This is really, can I make this smaller? There we go. Core to all software design, in my opinion, is format design. And format design is something that isn't really taught, and I wish people would teach it. I'm trying to write a really long article in a book about this because it really is what we do as software developers. And a lot of things are formats, if you think about it. An API is a format. It's a format for sending calls to some code. Files are a format. It's a format of how you store things in a file. Protocols like network is how do I store information in a way that's a format. Programming languages are formats. It's a way you store how, instructions for a computer, and it's also, you write in that instruction language. It's a format of what you can and what you cannot do in this way to describe instructions. So formats are really important. There are some things you should think about. One is the difference between semantics and structure, right? So sometimes you store semantics only. So for instance, the metric system is only semantics. If I tell you 3 meters, everybody can figure out what 3 meters is. But I'm not giving you, how do I structure that? I gave you that through words that came in sound. That's not defined. You can write it down on a piece of paper. You can, type it into a computer. It doesn't matter. A meter is a meter, right? We've described what semantically it means, but not structurally how we send it, right? And reversely, you can think of something like JSON. JSON is a format, gives you a structure for storing data, but doesn't tell you anything what that data means. There has no semantic meaning. It's an array of things, but it doesn't say what those things are, right? So you need to think about these things and what you make semantic and what you make structure. A lot of times you want to have a simple structure, and then you can have more complicated semantics, because then you can reuse code that reads the semantics, right? So JSON, again, a JSON loader can load any JSON. It can store healthcare data, or weapons data, or video editing data. Doesn't matter, right? Semantics doesn't matter. You can use the same loader for all these kinds of things, and that's kind of useful, right? But it also has its limits, because yeah, you can load it, but you can't really do anything with it because you don't understand it, right? You don't know what it means. And formats need to be implementable, and this is really, really key, right? It's like, if you want all these people to come together and work, if the API or the format is too complex, it becomes really, really hard, right? If I'm going to make a UI, and the data that I'm trying to make a UI for is super, super complex, then I'm going to half-ass it and make a UI that can only display like simple stuff, right? And then you start getting incompatibilities, right? People start saying, oh, I don't support those things. And languages are a great example, right? The larger a language you have, the fewer implementations you get, or the more bugs you get in your implementations, or, there's more things that, more people can't read it. It gets more and more complicated, right? Smaller formats are easier to implement, and therefore the quality of implementation are generally better, right? So you want to pack as much power as possible into a simple interface, right? A simple format. And that's the thing, is formats are two-ended, right? It's like, if you save a file, you have to load a file. If you send a network package, you have to load a network package. And if you make a complicated API, somebody has going to have to use that complicated API, right? So it's like a language, right? So the more you make it complicated for your, other people, you make it more complicated for yourself. And it sort of squares a lot of times, right? If you have 10 different people and they each want a feature, you're going to get, 10 features. And now everybody has to implement this. And a very common thing is to say, people say, I wish this file format, let's say we have polygons and NURBS. And some people think polygons are good, and some people think NURBS are good. And they say, I wish this was NURBS and not, But the problem is, if you support both polygons and NURBS, even if you want NURBS, you're going to have to implement NURBS and polygons. And the other end is going to have to implement polygons and NURBS. So now both have to implement the system they don't like and the system they do like, right? So everybody has to do more work. And it's actually better if you just pick one of them, and then some people are going to be less happy. But even if they're less happy, they only have to implement one thing. They don't have to implement two things, even though, it's better to implement one bad thing than implement one bad thing and a good thing. That's more work, right? So you really want to make it as small as possible. So make choices. That's really important, right? Like, a lot of people, when it comes to formats, it's like, look, my format can do a million things. And whenever I see that, that's like your format's going to fail because nobody's going to implement all those things, right? And also manage constraints. Like what can I require? What's the requirements of this format? If I know certain things, then that helps, right? If I know that all the data coming from the core of the fighter jet is in metric, that's great. I can, do that. Or even if I don't like metric, maybe the core lets me choose, and I know that I can be guaranteed that it gives me feet if I want feet and meters if I want meters, and the core is going to handle that for me. That's great. I can rely on that. It's, I don't have to think about it. Think about interactions. That's a very core thing. If we're making a video editor, we have a timeline, or do we have multiple timelines? Do we have a video stream, or maybe we want to support multiple video streams? Are we supporting stereoscopic video, or maybe we want to have like video all around us, like 50 displays at the same time? Can we edit that? Can we, and this is really important. Like, how many interactions do you have, right? And it goes for almost everything. Like, can this fighter jet have one radar or many radars, or can it have a worldview, or can it have multiple worldviews? Can I, should the pilot be able to pull up a worldview from another plane? Is that a useful thing? Or do they live in the same world? Like, who knows, right? These are things you have to decide. And it's really easy to forget to split them up and get too little interaction, but it's also really easy to have too many levels of interaction. So it's like, it's really, really complicated to traverse and find the thing you want, right? And then you want implementation freedom. And I talked a little bit about that, about the healthcare system. You want to basically say, this is how you talk to me about healthcare, but how I implement healthcare is none of your business, right? There's many, many different ways to build a server farm that holds healthcare data. And I want to be able to change that. And I don't want to, in my API, say, oh, you can, if my API has a function that says, oh, you can send in your own SQL query, right? And I allow you to do that. Well, then all of a sudden, now I'm required to have an SQL query language. And if they start sending queries for certain properties, those properties have to be in that SQL query and work. And now I've locked myself into SQL on the back end, right? Now I'm screwed, right? And if I want to move to a backend that doesn't use SQL, game over, right? So you really, really want to make sure that you put locks between these things. And basically, same thing with text rendering, right? You can do it as a bitmap, you can do it as curves or polygons or whatever. The user just draws text. They don't have to know how it's implemented. So if we want to change our implementation approach in the future, we can do that. Okay, another big question is plugin systems. So do you want a plugin system where you plug yourself in or you get plugged in, right? So I tend to think if you can make things that can get plugged in, that's good, because you don't want other systems to dictate how your code works. And I said this before, it's like, you don't want to live in somebody else's world. You want to live in your world and accept other people into your world. You don't want to go into somebody else's world and live in their world. So when you make a plugin, that plugin lives in your world. It lives in the world of the thing it plugs into, right? So if you can make things that are not plugins, then that's a good thing. If you can make them as modules that are standalone, that do not require to be plugged into something, that's a great thing. But a lot of times that's not possible. So therefore, plugin interfaces are often the right way to go. But if you can, try to make things that can be plugged in, can be reused and plugged into other things. That's it. That's my talk. So I would definitely like to thank everybody for watching. And you can always find me on stream on Twitch or at kelsolar.com or on my Twitter or all the other socials at kelsolar. Thank you for watching. Bye, everybody.